dear students, welcome to Nuclear Physics 1 lecture number 8. I'm Dr. Pervez Ahmed. In this particular lectures, we will trying to justify the questions to find the answer for the questions that why electron cannot reside inside the nucleus. We will try our level best to answer the questions with the logic from the literatures that why electrons cannot reside inside the nucleus. So let's proceed towards today's lecture. So you know that before 1932, it was believed that nucleus contains protons and electrons to give the net positive charge, that is Za. That was believed before the discovery of the neutron in 1932. Um, an example and a good example of that is a helium. From helium, we mean helium 4. Its nucleus contains 4 protons and 2 electrons and its nucleus. And that was the belief before the discovery of the neutron. People used to say that a helium nucleus that is called alpha particles contains 4 protons and sorry, a helium contains 4 protons and 2 electron and its nucleus. So that was believed before the discovery of the neutrons. So the presence of the electron and the nucleus is unsatisfactory. And what is the reason for that? The reason for that is there is no evidence of electrons proton strong interactions. The scientists have worked out to find out the evidence for the strong interaction. Any particles that if it want to lie inside the nucleus, so it should have strong interactions. You know that whatever the particles we have inside the nucleus, so for their presence, the strong interaction is necessary to be there if they want to lie there inside the nucleus. So the scientists they have found no evidence of the electron proton strong interactions. So what it means, it means that a nuclear electron need to be bound to the protons by a very strong nuclear force, but so far no such evidence has been found. So therefore it is evident that that is the first reason that we can say with surety that electron cannot reside inside the nucleus. And the reason is that it do not observe or do not feel the strong interactions. The scientists have not found any evidence for the electron proton strong interaction. So this is the first reason where we can say that or we can justify that why electron cannot reside inside the nucleus. The second reason is the uncertainty principle in quantum mechanics demands electrons inside the nucleus to have energy that should be equal to approximately 20 mega electron volt, which is generally less than 1 mega electron volt. This is according to quantum mechanics uncertainty principle. If you want an electron to reside inside the nucleus, so it should contain an energy approximately equal to 20 mega electron volt. But if we observe that in reality, so in reality this energy of the electron is approximately equal or less than 1 mega electron volt. So here you can consider this practically, that is if you want to confine electron in a space as small as nucleus, which we roughly take here the diameter that is approximately equal to 10 raised to power minus 14 meter. So for this, electron should have a momentum distributions in range of approximately equal to 20 mega electron volt per c. But keeping in mind that if you have your observations, so you will find that electron that are emitted from the nucleus through beta decay have energies generally less than 1 mega electron volt. So that is the second reason where we can say that why electron cannot reside inside the nucleus. That is, in order for the electron to reside inside the nucleus, it should have an energy approximately equal to 20 mega electron volt. But the observed energy for the beta decay during the emission of the beta decay, that is beta negative, it is found to equal or less than 1 mega electron volt. So uh, and this much of energy is not possible for the electrons to have it at that particular circumstances. So that is the second reasons where we can say that that's why electron cannot reside inside the nucleus. Reason number third, total and intrinsic angular momentum disagree with the observed value. How is that? So that we can easily understand from example. And as an example, we have deuteriums. So deuteriums demands 3 by 2 or 1 by 2 spin, but it's only 1. I mean, if we consider the example for intrinsic angular momentum of the deuterium, so deuterium demands that it should have intrinsic angular momentum either equal to 3 by 2 or 1 by 2, but the practically observed value is only 1. So if we treat that according to proton electron hypothesis, so we can easily get that a neutron contains two protons and one electron. So then the total span should be either 3 by 2 or 1 by 2. But the observed spin of the neutron nucleus is 1. So that is the reason number third. That's why we say that the electron cannot reside inside the nucleus. That is, the total intrinsic angular momentum disagree with the observed value. Reason number four, uh, disagreement of magnetic dipole moment of the nuclei with the theoretical value. That is, nuclei containing unpaired electrons would have magnetic moment much more than the observed values. That is, I mean, we have the cases where we have a particular nuclei contain unpaired electron. So for that particular case, I mean, the observations say that it would have magnetic moment much more than the observed value. And that can again we can easily understand it from the example of deuterium. So for the deuterium, the observed magnetic moment is only 1 over 2000 of the electrons magnetic moments, uh, and that particularly indicate the absence of electron and the deuterium nucleus. So that's all we have for I mean to justify the answer that why electrons cannot reside inside the nucleus. So we justify in short we justify four reasons uh, that why electron cannot reside inside the nucleus. Hope you understand, you understood the logic for why the electron cannot reside inside the nucleus. So that's all we have for this lecture. Thanks for watching. See you next lecture very soon. Till then, bye bye.